और कोई नहीं है। तो तुम लोग को बोला था कि when you go talking about limit extends to c f of x, है ना, suppose f is a function from some subset of R to R. Suppose f of f is mapping from AB to R. Then you are talking about some point C belongs to AB and whether this limit exists or not, right? So in order to, when you talk about the limit extends to C, this C should be a limit point that I have told you. Is it okay? C should be a limit point. याद रहेगा? C should be a limit point of I. याद रहेगा? हेलो, याद रहेगा कि नहीं? याद रहेगा? तो जिस पॉइंट में तुम लिमिट कैलकुलेट कर रहे हो, लिमिट ऑफ द फंक्शन, दैट जिस पॉइंट में, दैट पॉइंट शुड बी ए लिमिट पॉइंट. ठीक है, लिमिट पॉइंट ऑफ आई. एंड व्हाट डू यू मीन बाय लिमिट पॉइंट? दैट if you consider any neighborhood of C, if you consider any neighborhood C, it should contain some other point, okay, rather than C. So that's why I told you that C should be a limit point if there exists a sequence xn belonging to I minus C such that xn converges to C. That means xn belongs to I minus C and xn converges to C. That means if you consider any neighborhood of C, what do you mean by neighborhood? Neighborhood of some point. When you talk about epsilon delta definition, we are calling delta neighborhood of C. What do you mean by delta neighborhood of C? So this is, what do you mean by delta C minus delta? This interval in case of real line, huh? So this is one delta neighborhood of C. Okay. Is it clear? That means if you consider any neighborhood of C, it should contain another point, okay, other than C. Is it clear?
Yes.
So now when you talk about continuity, and if you define like this, then when you define f I subset of R to R, then there I am talking that when you talk about continuity at some point C, and if you want to use this definition, then C should be a limit point of I. That I told you. Is it okay? So in yesterday's class, you have any doubt? This already okay. I'm okay. So you have any doubt? Any? So this is your lecture 13. So till now you have any doubt? Or you have understood what we mean by continuity?
Sir, the last question which you were telling in the last class,
Yeah?
sir, there are difference or not? Sir, the question, sir, limit extends to C f of x till mod of x minus 3 greater than delta.
Which one? Which one?
That you wrote, sir,
I cannot hear
mod
you
of x
properly.
minus c. Yes, sir, this one.
Which one?
Sir, please put down.
Which one?
Sir, down.
This one?
Yes, sir, this one.
Okay, this is epsilon delta definition. Okay, so what do you mean by that? So okay, so using the limit, suppose f is said to be continuous at c if this holds. Is this definition clear? Then we'll talk about what do you mean
Yes.
by f. This definition is clear, right? That this fc should be defined, and already in case of limit you have studied that when a limit exists, and when you talking about just limit of a function, there you don't care what is happening exactly at c point. That means what is happening at c we don't care in the case of limit. But in the case of continuity, we said that when these two values are equal, we will say that f is continuous at c. And here x approaches to c, right? So in the case of limit, suppose we have seen that I told you that what is the difference between then limit and continuity, right? Suppose limit x tends to c, f of x equals to L. What do you mean by that? Using epsilon delta, can you recall what do you mean by that? Given any arbitrary positive epsilon, given any arbitrary positive epsilon, that means epsilon greater than 0, right? There exists a delta positive such that whenever 0 less than x minus c less than delta, you will get f of x minus L less than epsilon. Is this definition clear? So here you can see that we have put here 0 is greater than mod of x minus c. That means we are excluding the point. We are excluding the point. This one, we don't care what is happening at the point c. Okay, for this functional value, we don't care. That means we are considering about this kind of interval minus 1 point. So x belongs to this one. Is it clear? So when you talking about limit at some point, we don't care what is happening at c. That means we don't care what is the value of f of c, whether this exists or whatever you can define. We don't care. Is it clear in the case of limit? Hello.
Yes.
Now in the case of continuity, what we are saying that given any epsilon positive arbitrary, same there should exist delta such that whenever mod of x minus c less than delta, it should imply that f of x minus f of c less than epsilon. Is this clear in the case of continuity? Continuity at c. So here we also care what is happening at c. Okay, that means here what is happening at x equals to c, that we also need to care in the case of continuity. Okay, is it clear or not?
Yes.
Okay, now suppose f a2 b2 r. Okay, this is a function. Suppose, so then f is said to be continuous at the left end point. point A. Then how will write in terms of the limit? How will write f is said to be continuous at the left hand point if, how you should write, if limit x tends to a plus f of x equals to f of a. Is it clear? Whatever you have studied in limit, that will be used again and again. Okay, is it clear or not? Because your, suppose this is a here, this is b. When you talk about, and this endpoint are included, right? And when you talk about continuity at some point A, that means there is no point in this domain, right? This is domain. So you have to always consider this right neighborhood, right? And when you talk about some point endpoint B, left right endpoint, then you have to consider this left neighborhood. Is it clear? So f is said to be, similarly we can use using epsilon delta one sided, right? Earlier you have done. At b if limit x tends to b minus f of x equals to f of b. Earlier you have seen also, right? What do we mean by limit x tends to c plus f of x, limit x tends to c minus f of x. Is it clear? So suppose this function f of x equals to s. Is this function continuous?
Yes, sir.
Why?
Sir, for any limit x tending to any other, sir, sir,
So
for
at we,
x tending to c, it equal.
So you can see that this is continuous at every point, is not it? What about this function mod x?
No sir, it will
Also continuous.
सर ये कंटिन्यूअस कैसे आएगा?
कैसे नहीं आना चाहिए बताओ, क्या दिखाना है तुमको? Given any arbitrary positive epsilon, whether you can find a delta such that when mod of x minus c less than delta, you will get f of x minus f of c less than epsilon. That you have to prove, right?
Yes sir.
And where will be the difficulty? So suppose epsilon is your positive number, right? Now you have to find a delta. Does that? So let's see whether you can find a delta. This should be less than epsilon, right? So what is this quantity? Mod x minus mod c. This is this one, right? And that should be lesser equals to, that should be lesser equals to this should be lesser equals to what value?
Epsilon.
Huh? That we have to prove, that we have to prove that is less than epsilon. F of x minus f of c, right, equals to mod x minus mod c, and that is lesser equals to
Mod x minus c.
mod x minus c, right? Now can you see the proof? This is the main line of the proof, right? Now given any arbitrary positive epsilon, okay, you have to see whether a delta exists or not, right? So whenever mod of x minus c less than delta, okay, so given epsilon positive, and here what you have to choose delta? Here what we have to choose delta? Batao, what we have to choose delta? The
What?
proof is already What do you have to choose? Delta. This is less than delta, right? Because x minus c, that you have to find delta. And what you have to choose? Delta. Is it so difficult? What do you have to choose here? Delta. Delta you should choose in terms of epsilon and the point c. But here, since the function is mod x, right? So what you should choose? Delta. What is your objective? That f of x, whether you can find a delta such that f of x minus f of c less than epsilon or not. That can, here you have not shown it or not. So what is your delta here? You can choose various delta, but just give one example of delta that will work for this example. What should be your delta then? What should be the delta? You have to find it, right? Can you find it or not? This is a trivial example, right? And if you have difficulty, let me know, because you have already studied in case of the limit. What should be the delta? Anyone? Anyone? So delta should be your epsilon, right? Delta should be epsilon. If you choose delta epsilon, then you have shown that f of x minus f of c less than epsilon. Is not it? Is it clear? So you have shown that f of x is continuous everywhere. So c is here arbitrary. So f of x is continuous everywhere. So this is your example 2. Example 3. What about sin x cos x? What about sin x? Is it continuous? Is it continuous, sin x function?
Sir.
I will show it. I will show it. Sin x function is continuous. How will you show it? Sin x function is continuous. What about these functions? Box x. First, tell me whether sin x function is continuous or not. How will you show it? I will show it. I will show it. Whatever you have, you can show it in various ways, but suppose we want to show using epsilon delta. Okay. Then you can use your trigonometric identity, right? I will show it. So suppose here you want to show sin x minus sin c. So can you show it that this should be your less than epsilon? Means, can you show it? Can you show it or not? what do you have to use here? Then you can see that your delta equals to epsilon will work, है ना? So for any delta lesser equals to epsilon will also work. So how will show it? At least someone, how will show it? That sin x minus sin c lesser equals to mod x minus c. That you should tell. Sin of a, you have shown it, right? Sin b. But how you should write? Sin a minus sin b? How you should write for a minus? So you can see that, right? This is like a minus b. So that should come. So what you should do? What trigonometric identity you have to use? What trigonometric identity you have to use?
Sir, sin C minus sin D.
So what you will get? Sin x minus sin c. How should you write that? This is equals to, how should I write this? Sin x minus sin c.
2 cos x plus c by 2 cos x minus c by 2.
2 cos
Sin
x plus
x
c
minus
by
c by
2 and sin x minus c by 2 is not it? Now what is the value of cos x? This one. What is largest value? So this you have got, right? And this is lesser equals to, it's already done. This is lesser equals to, is it clear? So ultimately you will get x mod of x minus c. Is it clear or not? So you are getting 2 sin x minus c by 2. So that is lesser equals to x minus c. Course, because here you will see, and you can choose, and this is your less than delta. You have to choose it. So you can choose it epsilon. Is it clear? Is it clear or not? So what about these functions? F of x equals to box of x. Is it continuous? Is it continuous box x function?
No, sir.
No, sir.
Why? Why it is not continuous? Why it is not continuous?
Limit extending to x plus will not be equal to f of x.
So this is not continuous at which point? So see, earlier we have, when you are talking about that this function is continuous, that means this function is continuous at every point. This function is continuous at every point. Okay.
कंटिन्यूटी वाली थ्योरम लगा देंगे सर, एक पॉइंट के अबाउट कंटिन्यूटी की थ्योरम लगा देंगे.
But this function is continuous at which point? And this function is not continuous at which point? Can you tell? Is not continuous. Where?
At integer.
Should be. Can anyone? This function is not continuous at c, right? That means c should be
इंटीजर.
yes.
Integer.
So if C is an integer. Because your left hand limit and right hand limit will be different, right? Your left hand limit, so here you can show using left hand limit is not equals to right hand limit. What about this function? F of x equals to sine 1 by x when x not equals to 0. Okay, and 0 when x equals to 0. Is this function continuous at 0? Check continuity at 0. Is this function continuous at 0?
No, it will be
Why?
oscillating maybe.
So that means I told you when that using sequential criteria you can show, right? Using sequential criteria you can show that if two sequence converges to yeah, in case of limit already you have done it, that this already you have done it. The limit should exist how in sequential criteria, and that limit should equals to your f of c, right? So you should consider two sequence such that they converge to because this limit should be always unique. But if you don't get unique, that means the limit does not exist, right? And I told you when you want to show that the limit does not exist, one of the best criteria is sequential criteria, because there you can see whether two sequence converges to C at the point where you want to check continuity or limit. Then you can see that there. So you can choose two sequence x and y and they converge to 0. But there this sequence they converges to different value. That means this limit does not exist. So f of x is discontinuous because in order to this limit exist, so this should exist, right? In order to be continuous, this should exist first. I told you, right? If it does not exist, then means this function is not continuous. I told you here in the previous class. Told you in the previous class, right? Yeah. See, fc should be defined. This limit should be exist. This limit should be exist, and they should be equal. So if this limit does not exist, that means the function is not continuous. So sequential criteria will be useful if you want to check the function is discontinuous at some point. So what are the sequence for this function you should take? Already you have done in the previous class, maybe on Monday you have done. I think on Monday you have done it, right? So what should be the sequence xn and yn? We want to check continuity at 0. So that means this limit should exist and equals to f of c. But suppose the limit does not exist, okay, then the function is discontinuous. So how will check? So what are the sequence that already you have done? That xn we have chosen. Xn is, can anyone recall? 1 by n pi, right? If xn is 1 by n pi, that goes to zeros because you want to check continuity at 0. And what about f of xn? What about f of xn?
1 by n pi by 2.
No, sin n pi, right? sign that should also goes to 0. Then you choose another sequence yn 1 by 2n plus 1 pi by 2. But this sequence goes. But this sequence goes
0.
0. What about f of yn? Why does this go?
1.
1. That you have already done, right? So see, this limit is not unique here. That means limit does not exist here. So function is f is discontinuous. It's not continuous. Okay, discontinuous at x equals to 0. Is it clear? Is it clear? Is it clear? How will check using sequential criteria if the function is discontinuous? When you checking the function is continuous, how you have shown using epsilon delta, or in the case of limit. Is it clear? Similarly, if two functions are continuous, then their addition and subtraction will also be continuous. Whatever you have shown in the case of limit, similarly for continuity also. Okay, so I should write it here. If g, suppose they are function from I to R, be continuous at t belongs to I, okay, and some scalar suppose R belongs to R, okay, then f plus minus g, f g, r f are continuous at C, okay, and suppose and if g of C not equals to 0, then f by g is defined in a neighborhood of C, okay, and is continuous at C, okay. Any doubt? So if two functions are continuous at some point, their addition, subtraction, scalar multiplication also continuous. Product of two continuous function is also continuous. And if some function, so if you take some function in the denominator, if that should be not equals to 0 at some point, then you can talk about continuity of the rational type of functions. Okay. So suppose any polynomial function, I will write. So suppose p are 2r, any polynomial functions, p of x is an x to the power n plus an minus 1 x to the power n minus 1 plus an a0. What I should write? A0? What I should write? Some constant, huh? a1, a1x plus a0. Okay? So a0, all this a belongs to R. Is this function continuous? Is this function polynomial? Is this continuous? What do you think is continuous? Okay, because this function, constant function, this is your 1 degree polynomial. So all this n minus 1 degree polynomial, n degree polynomial, these are all continuous functions. Okay, and their summation is also continuous because by the property of these properties. Is it clear? You have any doubt till now? You have any doubt till now? Then different type of continuity and different type of discontinuity. Okay. Suppose you defined, so this you have studied, I think, right, in 12th class, removable. What do you mean by removable discontinuity? So suppose f of x equals to x square minus 1 by x minus 1 x not equals to 1 and alpha x equals to 1. Okay. Alpha is some value, right? So is this function continuous at 1? Is this function continuous at 1? What do you think? Is this function continuous at 1? So what is the value of this? Limit x tends to 1 f of x. What is the value of this? Huh?
2.
2. Right? So this value is 2. Now in order to continuity at x equals to 1, okay, then this value should be equals to your f of in order 1, right? Then function is continuous and f of 1 is you have defined alpha, right? So if alpha equals to 2, then only f is continuous
at 1.
at x equals to 1. If alpha not equals to 2, then f is not continuous at x equals to 1. So that means, so removal. So you can remove the discontinuity. Suppose alpha not equals to 2, then the function is not continuous. Now if you define alpha equals to 2, then the function is continuous. That's why this type of singularity is known as removable singularity, removable discontinuity. Okay, this we have studied, right, in your 12th class. Now there are other type of discontinuity also, right? Do you know what do you mean by other type of discontinuity? Suppose limit x tends to c f of x does not exist. Okay, f of x does not exist. Then what will happen? What will happen? So two cases will arise, right? So both limit x tends to c plus f of x or limit x tends to c minus f of x or both does not exist. Is it okay? So f of x, suppose 1 by x, x not equals to 0, and at x equals to 0, so f of 0 is some value, f of 0 any value. Okay, so is this function continuous at x equals to 0? Is this function continuous at x equals to 0?
Sir.
Huh?
No, sir.
Why?
Sir, because at x equal to 0, fx is not defined.
Huh?
Sir, for x approaching to 0, fx is not defined.
Where? F of x is defined everywhere, right? F of x is 1 by x when x not equals to 0. And when x equals to 0, it's defined as f of 0, some value. Any value, it is right? You can take any value. So it is defined. Now you have to check whether the function is continuous at x equals to 0 or not. Is this function continuous at x equals to 0? That you have to check. Is this function continuous at x equals to 0?
No, it is not.
Why?
Because if you turn the limit to 0 minus, it will tend to minus infinity. And
Yes.
If we go to 0 plus, it will go to something
Plus infinity.
plus infinity. Yes, yes.
Right.
That's correct.
So this has an essential discontinuity. Okay. This type of essential discontinuity at x equals to 0.
I have a doubt. Can I have?
Yes, yes.
Suppose if there is a function like any arbitrary function, if we are willing to calculate the left hand limit and right hand limit,
Okay.
and for that particular function, both of the left hand and right hand limit do exist, but are not equal. But limits are not equal.
So
like in
that,
this case. So
that is known as
what
jump
we-
discontinuity. I'll come to. That is your question, I think, right? That is your question. Suppose this function f of x equals to 1.
No, not actually. Not actually. My question is not actually what you have said. एक पेज ऊपर जो आपने लिखा था कि से स्क्रॉल कीजिए ना ऊपर वो हाँ ये यहीं पे लिमिट एक्सटेंस एफ एक्स डज नॉट एग्जिस्ट देन आपने लिखा है कि सी प्लस पे भी एफ एक्स एग्जिस्ट नहीं करेगा
No, no.
सी माइनस पे
See,
भी
I
एग्जिस्ट
have
नहीं
written that limit extends to if it does not exist. Then I have given 1, right? First case. Okay. That either this limit or both does not exist. Okay.
Okay.
This is case under case 1. Okay. Is it clear? So what is your question? I think this one. Next one. What will come?
Yes.
So what is case 2? Case 2 is that both limits exist. So this is known as jump discontinuity. Okay. F of x and limit extends to c minus f of x both exist, but are not equal, right? Then it will be known as jump discontinuity. Okay. And the example is this example. Okay. So you can see that both limit exist or not at x equals to 0. Check continuity at x equals to 0 for this function. Continuity at 0. So what is your left hand limit?
-1.
-1. What will be the right hand limit for 0?
1.
1. So both limit exist, is not it? Both limit exist, but they are not equal, right? And you know that when the limit should exist, limit extension, that limit should be unique, is not it? So both c plus and c minus exist, but they are not equal, right? So this function will be f as jump discontinuity at x equals to 0. Is it clear? So you have seen 3 type of discontinuity, right? One is removable discontinuity. So where this limit exists, but this is not equals to your f of c. If that is the case, then this will be as your removable discontinuity. Okay. Next one is your essential. essential discontinuity, where either this limit or this or both does not exist. We have given one example, right? Then last one, jump discontinuity. Okay, so both limit exist but are not equal. So in that case, it will be called as jump discontinuity. So you have any doubt? Anyone?
उन्होंने पेपर कैलकुलेट देख लिया लेकिन एक फोटो कॉपी नहीं देख लिया मैंने देखे पेपर क्यों रुका पड़ा है उन्होंने बताया पेपर उसमें एकेडमिक्स बहुत हुआ लाइक कमेंट करके भेजें देखिए क्या करते हैं एकेडमिक्स वाले हम लेते हैं नहीं दिखा देंगे ताकि पेपर डिपार्टमेंट में वापस नहीं होगा
You have any doubt? No doubt?
Can you please give an example on discontinuity of some oscillating functions? Like among all those three discontinuities, how can you describe which discontinuity should be at that oscillating functions would cover?
See, suppose this kind of sine 1 by x. Okay. What type of discontinuity is there? Some values, What type of discontinuity is there? At x equals to 0?
There should be some values that we cannot actually define.
No. Then its value should be where? So
Why we cannot say that because that is an oscillating function. 1 by x tends to minus infinity to plus infinity, and sign of that function should not give an accurate result.
what kind of discontinuity you will get at x equals to 0? Suppose this is the function, okay? 1 by x square, x not equals to 0, okay? And f of 0 at some value, some value when x equals to 0. If this is the function, suppose, what is the discontinuity type? What will be the discontinuity type? What will be the discontinuity type?
Like jump discontinuity.
This one?
Maybe. Yes.
This one?
Jump discontinuity maybe.
So when you say that limit exists, what do you mean by that? When you say limit exists, what do you mean by that? Suppose when you say limit x tends to 0 plus f of x exists, what do you mean by that? What do you mean by that?
I think integral should exist, that fx should be defined at that.
No. What do you mean by that? This limit should be some finite value, right?
Yes.
So if it is infinite, okay, then can I say that limit exists?
No.
So limit goes to infinite, right? Then infinite discontinuity. Is not it? Limit goes to infinite. So it is infinite discontinuity will get. Okay, we'll come to that. I have another class, okay? So we'll continue from here. So please look at some books. Already references are there, right? Thomas and other books also. So please study some basic definition of continuity, whatever you have studied in 12th class. Okay, using epsilon delta sequential criteria.